Now we come to this experiment of double slit interference. Now we have set up the slits on the goniometer. We put a narrow slit spacer which has been mounted on the cube and has an extender scale at the back. We're using two metal reflectors by the sides of the spacer, and we've adjusted the slit spacing to be roughly about 1.5 centimeter for this experiment. These large reflectors are necessary because once the wave passes through this, we want the interference to be developed when the signal passes through these two slits. Now interference pattern will be developed along the space here, and these two big reflectors help in isolating the space at the back and at the front. Now for this particular case, the mathematical relation will be d sine theta is equals to n lambda. Now d is the spacing. Now as I move the receiving horn, I can see the change in the received signal strength. Right now my received signal strength is 46.5, which is approximately the maximum. Now as I move the receiving horn, the signal strength goes down. It goes to 40. Now it still goes down to 35, 33, and it will hit a minimum. Now it has hit a minimum here. We can note down this particular angle. We can note down the readings at every step, and we can take a plot. Now after this minima, this signal will start increasing again, as you can see on the digital display here. This digital display helps us because we have a huge dynamic range available to us of about 60 to 70 dB, so we do not have to adjust the distances all the time as would be the case in an analog instrument. We have a digital scale with a higher log range available to us. This is a plus point of our equipment. Now as we move it again passes through a maxima, and on further increase it again passes through a minima. So we can take a note of these readings and we can perform our experiment of diffraction of signal when it passes through slits. Now to modify, we can change this narrow slit with a wider spacer, and we can have a variety in the experiments, and we can prove the laws of electromagnetic diffraction.